Hello. In this video, we're going to continue graphing trig functions, and we're going to start looking at some changes to the horizontal values. So here we have y equals sine of theta minus 90 degrees, and that means we're going to have a horizontal translation. So this here means a horizontal translation, and it's going to be 90 degrees to the right. Because remember, we take the value, and if it's subtraction, then we do the opposite, which is adding. So let's take our base graph here, which is going to be 0 degrees, 90, 180, 270, and 360. 0, 1, 0, minus 1, 0. And then we're going to go ahead and create our new transformed graph. So the y values all stay the same because we don't have any vertical transformations yet. But the x values all get added 90. So 0 becomes 90, 90 becomes 180, 180 becomes 270, 360, and then adding another 90 will be 450. So let's start labeling these. We've got 90, 180, 270, 360, and 450. Now, because they're degrees, we technically need to make sure that we have the degree symbol on them. And the y values go up to +1 and down to -1. All right, here we go. This point, this point, this point, this point, and this point. We connect the dots. Oh, that was a little messy. Let's try that again. There we go. And there's our nice, beautiful sine graph. So again, this is the same as before. Whether you're doing vertical or horizontal translations, you just take the base graph and you apply the transformations. Here again, if we want to be specific, it's the x values where we're going to add 90 degrees to them. And away you go. So let's go ahead and do another one. But this time we have some vertical and some horizontal. And because this says 3 pi over 4, we're going to assume this is done in radians. So that means our base graph has to be in terms of radians. So we'd have here x and y, 0, pi by 2, pi, 3 pi by 2, 2 pi, 0, 1, 0, minus 1, 0. Now the x values, we're going to add 3 pi over 4. For the y values, we're going to multiply by 2 and then subtract 4. All right, so now we have our new x and y over here. So pause the video and see if you can come up with this new table. All right, let's do the y values first. 0 times 2 is 0, minus 4 is -4. Then we get 2 times 1 is 2. Minus 4 is -2. Back to -4. This will be down to -6. And then back to -4. All right, the x values are tricky. We have to add 3 pi over 4. So 0 plus 3 pi over 4 is just 3 pi over 4. But now we have to do a little bit of fraction work, right? We have pi over 2 plus 3 pi over 4. So maybe I'll do that on the side here. Pi over 2 plus 3 pi over 4. That's the same as 2 pi over 4 plus 3 pi over 4. So that will be equal to 5 pi over 4. Now we have a pi plus 3 pi over 4, so that will be 7 pi over 4. And you might start to notice a pattern, but if you have to write them all out by hand, that's fine. 3 pi over 2 plus 3 pi over 4. That's 6 pi over 4 plus 3 pi over 4, which is 9 pi over 4. Then the last one will be, well, you have 2 pi, which is 8 pi over 4. So 8 plus 3 is 11 pi over 4. All right, so we got to plot these on the graph. We've got 1, 2, 3, 4, 5, 6. So -2, -4, -6. The x values are a little tricky here. We've kind of got like pi by 4s. So if you were to do it, you could make 11 tick marks, each a pi by 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is pi over 4. And so this will be 3 pi over 4. Then 5 pi over 4. 7 pi over 4. 9 pi over 4. And 11 pi over 4. That's probably the easiest way to make the tick marks. So here, each tick mark is pi over 4. All right, let's grab those points. So 3 pi over 4 and minus 4. 5 pi over 4 and minus 2. 7 pi over 4 and minus 4. 9 pi over 4 and minus 6. And 11 pi over 4 back there. So again, we connect the points with that nice, beautiful sine shape. And we can see here that the amplitude, or the height of the graph, we have a vertical stretch. It's been made twice as high. We can see here that the graph has been moved down 4. That midline, or the middle of the graph, is down 4. We can see the graph has been moved to the right by 3 pi over 4. So we can visually see, you can imagine the original graph is here, and the new graph has been moved this way, and stretched. So hopefully we can visualize those transformations. But again, as long as you take the old ones and then you make the new ones, you should be good to go. All right, go ahead and pause the video and give it a try. All right, let's take our old values. Again, this is going to be in radians because of that pi. So we have 0, pi by 2, pi, 3 pi by 2, and 2 pi. And this is going to be 1, 0, minus 1, 0, and 1. Our new values over here. So the x is going to get add 5 pi. The y is going to get times by negative 3, and then add 4. Again, I like to do the y ones first. It's a little bit easier. 1 times negative 3 is negative 3 plus 4 is 1. Then this will be 4 minus 1 times negative 3 is 3 plus 4 is 7. This will be back to 4 and then back to 1. Okay, now the x values, well, 0 plus 5 pi is just 5 pi. But pi over 2 plus 5 pi is a little tricky. Pi over 2 plus 5 pi is pi over 2 plus 10 pi over 2, which is 11 pi over 2. Then we have 6 pi. 3 pi over 2 plus 5 pi is going to be 3 pi over 2 plus 10 pi over 2. So that's going to be 13 pi over 2. And then this is 7 pi. Now, these are tricky to graph, and I would almost recommend we write these as a fraction. 5 pi is the same as 10 pi over 2. 6 pi is 12 pi over 2. And 7 pi is 14 pi over 2. Might be nice to put them all as pi over 2s because, that's just going to help us with our sketch. Additionally, I think my initial table is going to get in the way, so I'm just going to go ahead and move this. All right, get that out of the way here. So when we go to sketch the graph, we could put these pi over 2s along the bottom, and we don't have to worry too much about scale. Like, I know if you think about it, 1, 2, 3, 4, 5. 5 pi might be out here, but that's like it's going to really make our axis hard to visualize. So what I might do is I might just kind of start here. I might call this 10 pi over 2, 11, 12, 13, 14. Right, 11 pi over 2, 12 pi over 2, 13 pi over 2, and 14 pi over 2. The important thing is that the tick marks are equally spaced. It's not really important, this distance here. This is a little bit irrelevant. Sometimes on more professional looking graphs, you might actually have a broken line here just to show that there's going to be a little bit more space. But the basic idea is we're zooming in on the section that we have the table for, and we can kind of ignore making them exactly the right amount from the original origin. Now let's go ahead and put the marks along the y-axis. So 1, 2, 3, 4, 5, 6, 7, 1, 4, and 7. Those are the important ones. All right, and let's go ahead and sketch the graph. I'll do it in green just for fun. So we have a point down here, a point here, point up here, down here, and down here. Now remember, we don't want to do that because that's not the coast graph. The coast graph is supposed to have some nice curvature to it. And the coast graph will continue on again, so we need to add those arrows, but make sure they're going back in the right direction. Right, it would be incorrect if I drew it like this, because that's not where the coast graph goes. Technically, the coast graph would continue like this, right? Making, again, that wave shape. Now, can we visualize these transformations? The reflection, definitely, the coast graph usually looks like a valley, now it looks like a hill. The stretch, yeah, it's definitely taller. The vertical translation, yeah, it's definitely been moved up. And the horizontal translation, yeah, it's definitely been moved to the right. So all the transformations are present, and we've successfully sketched the graph. All right, so here's another one. We've added another value. We've added a 1/2 here, which is going to be a horizontal stretch before the horizontal translation. Again, it's in radians because it's pi over 2, so pause the video and give it a try. All right, so assuming you gave it a try, let's go ahead and look at our points. So again, we have here x and y, our initial values. For coast, we're going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. 1, 0, minus 1, 0, and 1. Now for the x, we have to multiply by 5 and then add pi over 2, because the 1/5 we have to do the opposite, and the minus we have to do the opposite. For the y, we multiply by 2 and add 2. All right, let's look at our new table. So for the y values, 1 times 2 plus 2 is 4. 2, 0, 2, and 4. For the x values, we're going to have, these get a little tricky. 0 times 5 doesn't change, so just pi over 2 to start. Now, pi over 2 times 5 is 5 pi over 2, plus another pi over 2 would be 6 pi over 2. Pi times 5 is 5 pi, but 5 pi plus pi over 2, again, we need to make common denominators here. So this would be 10 pi over 2 plus pi over 2, which is 11 pi over 2. Now 3 pi over 2 times 5 is 15 pi over 2. You just multiply the 3 and the 5, plus another one is 16 pi over 2. And then the last one here, we'd have 2 pi times 5 plus pi over 2. So that's 10, which is 20 pi over 2 plus a pi over 2, so that's 21 pi over 2. Now you might be wondering, 16 pi over 2, that simplifies to 8 pi, or 6 pi over 2, that simplifies to 3 pi. But again, it's easier to leave them as pi over 2s because it just helps when we label the axis. So let's go ahead and take a look here. For the y-axis, we're going to have 1, 2, 3, 4. Looks like my tables might be getting in the way. We'll move those in a minute. And then for the x-axis, well, they're all pi over 2s. We might be able to make 21 tick marks. Might be a little tricky. So what we might do is just go pi over 2, then 6 pi over 2, then 11 pi over 2, 16 pi over 2, and 21 pi over 2. The nice thing about the sine and cosine graph is the points are always equally spaced. So you can kind of just, again, eyeball it. Put down the points, label them properly, and then we should get full marks even if it's not exactly perfectly spaced like on a computer. Let me just go ahead and move these tables out of the way. All right, so we just got our table off to the side. We don't need our original table anymore. So here we go. We've got pi over 2 and 4, 6 pi over 2 and 2, 11 pi over 2 and 0, 16 pi over 2 and 2, and 21 pi over 2 and 4. Again, it's important. This here would lose us some marks for many reasons, partly because the arrows don't continue on this way. The graph has to have some curves, and we certainly don't want it to be sharp at the bottom. So again, we're looking for like a nice, beautiful shape like that. And there we have our graph of cos with a bunch of transformations. All right, one more to try. We have negative sine pi over 2 theta minus 1. Go ahead and pause the video and give this a try. All right, assuming you gave this a try, we take our initial table with 0, pi over 2 pi, 3 pi over 2, 2 pi, 0, 1, 0, minus 1, 0. The x's are going to get multiplied by 2 over pi. That's kind of weird. The y's are going to get multiplied by negative 1 and then subtract 1. So again, let's do those y's first. 0 times negative 1 doesn't change, so minus 1. Minus 1 is minus 2. Minus 1. Now, minus 1 times minus 1 is plus 1. But then we minus 1, so back to 0. Okay, and then 0 times negative 1 is 0. Minus 1 is negative 1. Okay, maybe those were a little tricky, but as long as you keep our negative straight, we should be good. Now the x ones. 0 times 2 over pi is just 0. But pi over 2 times 2 over pi, well, those cancel and those cancel, so you just get 1. That's kind of weird. Pi times 2 over pi is 2 pi over pi, which is 2. 3 pi over 2 times 2 over pi. The pi's cancel and the 2's cancel, so you get a 3. And 2 pi times 2 over pi. Well, the pi's cancel and 2 times 2 is 4. So this is kind of neat, actually. We have x values, 1, 2, 3, 4. These are like the nicest x values we've had all day. They don't have any pi's in them. They're not super weird. They're just, they're kind of nice. And then for the y values, we have minus 1 and minus 2. All right, let's go ahead and sketch away. So 0, negative 1, 1, negative 2, 2, negative 1, 3, 0, and 4, negative 1. All right, boom, there's our graph of sine. And what made these values nice is because there was a pi involved in the horizontal stretch. It kind of canceled with the pi's that are in the base graph, and we ended up with just real number, whole number, in fact, integer values for the x. This doesn't always happen, but it happens sometimes, and when it does, it's just really nice. It's changed the period of the graph, if you look, to actually 4. The period used to be 2 pi, which was, again, a bit of a gross number because it had a pi in it. But now the period is just 4, and I kind of like this graph. Looks kind of cool. All right, so let's go ahead and take some notes. So again, we're working on further transformations of trig graphs. And so if you think about it, the basic graph, or sorry, the general graph would be A sine B theta minus C plus D. And so if you think about the original table with x and y, or you could think of theta and y, it doesn't really matter. If you think of the original table of x and y, and you want to go to the new table over here, the new table, well, with something like this, the x would need to be multiplied by 1 over b and add c, and the y would have to be multiplied by a and add d. Those are the 4 transformations that would happen based on the 4 letters. And that's what you do. You just take your old table and you transform it into your new table. You just maybe have more transformations than the previous examples. For our example, let's sketch y equals cos pi over 4 x minus 2. Pause the video and give that a try. All right, so assuming you give that a try, let's take a look here. We have 0, pi by 2, pi, 3 pi by 2, 2 pi. And we have 1, 0, minus 1, 0, and 1. These are going to give us a new table. Let's do the y values first. They'll stay the same. 1, 0, minus 1, 0, 1. The x values need to get multiplied by 4 over pi. 4 over pi. And then we have to add 2 to them. Okay, well 0 times 4 over pi is 0 plus 2 is 2. Now pi over 2 times 4 over pi plus 2. Well, the pi's cancel, so you get 4 over 2, which is 2, plus 2 is 4. Okay. Pi times 4 over pi plus 2. The pi's cancel, and you get 6. 3 pi over 2 times 4 over pi. The pi's cancel. 3 times 4 is 12. Divided by 2 is 6, plus 2 is 8. And then the last one, 2 pi times 4 over pi plus 2. 4 over pi plus 2. Pi's cancel. 2 times 4 is 8, plus 2 is 10. Okay, so we're going to have the following. We've got 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Plus 1, minus 1. Let's go ahead and sketch it in blue. So here, 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 and here. And we'd have a graph that looks like that. Now, if you notice, this graph is suspiciously like the sine graph. If I actually, well, a few things. Let's notice a few things. First off, we have an interesting period here. It looks like the period to go from 2 to 10. It's going to have a period of 8. So that's kind of neat. We also notice that we have those x values that are whole numbers. That's neat. But like I was mentioning, if we extend the graph back to here, to the origin, and we look at one period here from 0 all the way to 8, this graph looks suspiciously like sine. Looks like sine x. And this is not a coincidence. The sine graph and the cos graph are both very similar. You can almost think of one as being a shifted version of the other one. And so this sometimes happens when you do enough transformations on a cos graph. Sometimes it starts to look like a sine graph. And again, I just find that pretty interesting. Now, for practice, you can look at worksheet 10 and 10.5. And then any things to remember. Again, I might write down some graphing tips. Things involving like the tick marks, right? The equal spacing. Not worrying too much about scale. So scale is kind of like optional. It's more important that you label all your points and everything looks right in terms of like they looks like a sine and cos graph. The scale being exactly precise is a little bit optional. If it's not quite to scale, don't worry about that too much. All right, hopefully you enjoyed this video, and as always, thanks for watching.